You ever notice how one single really vivid story can just completely knock over a mountain of data? Well, today we're going to dig into that exact quirk of the human mind. It's a bias that shapes our judgment every single day, and we barely even notice it. We're going to use a simple little puzzle to uncover a really complex truth about the way we think. Okay, let's just dive right in. I want you to try and solve a puzzle with me. Just listen to the details and honestly just go with your gut. So here's the scene. A cab was involved in a hit-and-run accident late one night. In this city, there are only two cab companies. That's it. You've got the green company and the blue company. All right, here are the facts of the case. We know for sure that 85% of all the cabs in the city are green and only 15% are blue. Now, a witness saw the whole thing happen and said the cab was blue. And to be sure, a court tested this witness's eyesight and found that, under these exact conditions, they're reliable 80% of the time. So what's the probability that the cab was actually blue? You know, most people's gut feeling just grabs onto that 80% reliable witness. But is that really the whole picture? Okay, now let's see what happens when we tweak just one little detail. We're not going to change the numbers at all, just the story behind them. And this is where it gets really fascinating. So this gets right to the heart of the whole puzzle. Mathematically, the information on both sides is identical. But psychologically? Oh, they are worlds apart. On the left, you just have a plain statistic. But on the right, you get a story, a causal story. The companies are the same size, but those green cab drivers, they're reckless, and they cause 85% of the accidents. See what happens? Your brain processes that second version completely differently. All of a sudden, you formed this little stereotype of a reckless green driver, and that story starts to push back against what the witness said. What this puzzle does is it just perfectly reveals these two different ways our minds handle information, what the psychologist Daniel Kahneman calls base rates. And it turns out we have a really powerful built-in preference for one type over the other. So the first type is what's called a statistical base rate. This is just a cold, hard fact about a population, like, the percentage of green cabs in a city. Our minds tend to see this as abstract, kind of disconnected from this one specific event, so we pretty much ignore it. But then you have the second type, a causal-based rate. Now, this is information our brains can instantly weave into a story. Green cab drivers are reckless. That isn't just a number anymore. It feels like an explanation for why the accident happened. It creates a stereotype that we instinctively apply to this one specific driver. So here's the crucial point. While the word stereotyping has a deservedly negative reputation in our society, from a purely psychological view, it's just a fundamental way our brain tries to make sense of the world. The big takeaway here is that our brain is super quick to use a story that explains why something happened, but it's incredibly slow to use a statistic that just says how often it happens. And this bias, it's so deeply wired into us that it can actually stop us from learning, even when we're flat out told some surprising facts about human nature. Let's look at another classic psychology experiment to see just how this works. All right, so in this famous study, psychologists set up a scenario where people were in separate rooms and they could hear someone over an intercom who was pretending to have a seizure and was crying out for help. The catch? Every single participant knew there were other people listening in who could also help. This creates something called diffusion of responsibility. The results were, well, they were shocking. Out of 15 participants, only 4 of them immediately rushed out to help. The rest? They either never left their room or came out way later. What the experiment showed is that even good, decent people often just don't act in an emergency when they think somebody else might. But here's the real kicker. When the researchers told a group of students about this startling result, this statistical fact about human behavior, it had absolutely zero impact on their thinking. When they were shown videos of 2 of the people from the study, they still confidently predicted that those individuals would, of course, be helpful. They completely ignored the data they had just learned. So this raises a really fascinating question, right? If teaching people a surprising, powerful statistic doesn't actually change their beliefs, then what does? Well, the answer is both simple and pretty profound. So the researchers tried a different approach. Instead of giving the group statistic first, they showed students videos of 2 perfectly nice, normal-looking participants and simply told them, these 2 people, they didn't help. And that small, specific, surprising piece of information, it worked. The students immediately generalized from just those 2 examples and finally understood the powerful influence of the situation. This fantastic quote from the researchers really just sums it all up perfectly. We are incredibly reluctant to apply a general statistic to a specific person.
But we are incredibly willing to create a general rule from just one or two specific, surprising stories.
So what's the key takeaway from all this? It's that our minds, they're not built like spreadsheets. We are fundamentally wired to understand the world through stories, through individual examples, and through things that seem to explain cause and effect. And that is why a single vivid case often feels more true to us than a general statistical reality. You know, this isn't just some abstract lesson from a psychology class. It is a critical thinking tool. So, I want you to ask yourself, the next time you hear a really powerful, compelling anecdote that seems to run counter to the data, whether it's on the news, in an ad, or just in a conversation, which one is your brain going to believe?